Welcome back. In this problem we're going to be finding out which graph best represents the inequality y plus 6 is greater than or equal to x squared minus x. Now I haven't given you the graphs from multiple choice because I think it's a very important skill to be able to graph any basic function, and that's what we're going to go through here. So when you're graphing an inequality, it's usually very helpful to imagine that, especially if it's greater than or less than or equal to, that we're going to graph it as though this wasn't a greater than or equal sign, but just an equal sign. So we're going to pretend this is just equals. So what if that was the case? What if we were just simply being asked to graph y plus 6 is equal to x squared minus x? That would be a lot easier, right, than having to deal with the fact that it's a greater than or equal to. Let's deal with that second. Alright, so how would this be done? Well, we'd want to get y by itself, right? And you can probably already guess, because this has an x squared and this has x to the first power and this is a constant term, this is going to work out to be a parabola, right? It's going to be a second order polynomial if we get y by itself. So let's subtract 6 from both sides and we'll get x squared minus x minus 6. And now you may be tempted to factor this, right? You could separate this out into, what would it be, y minus 3 times, x minus 3 times x plus 2. But that doesn't actually help you graph it. When you're graphing a second order polynomial, which is a quadratic, it's going to look like a parabola. So what you actually want to find out is where's the vertex, and does this thing go up or down, right? If you have a positive in front of the first term, then it's going to be a parabola that opens up. And if you have a negative in front, then that means it's a parabola that opens down. And the other thing you want to know is where's the vertex. So the way you find out where the vertex is, the x-coordinate of the vertex is equal to negative b over 2a. Now if you don't remember this, you're probably saying, well, where did that come from? Well, that is how you find the x-coordinate of the vertex. So what is a and b? Well, a is, if the polynomial is in standard form, then a is the coefficient of the first term, the squared term, b is the coefficient of the term to the first power, and c is the constant term at the end. So in this case, a is just 1, right? That's the coefficient of x squared. B is negative 1, that's the coefficient of the x, and C is negative 6, which we don't actually need for this bit. So the x-coordinate of the vertex is negative 1, that's B, over 2a, which is 2 times a, which is 1. So that's positive 1/2, right? Now what happens when we plug 1/2 back into the original function? Plugging 1/2 back in here, we can find out what the y-coordinate is. So y must be 1/2 squared minus 1/2 minus 6, which is 1/4 minus 1/2 minus 6. Now that math is a little tricky. We need a common denominator, right? So let's make the common denominator 4. So it's 1/4 minus 2/4, right? That equals 1/2. And how many quarters is 6? 6 times 4 is 24, so 24 quarters. And all in all, that will give us minus 25 over 4, which is a little less than negative 6, right? So what did we just find? We just found the coordinates x and y are the coordinates of the vertex. So the vertex is located at 1/2 negative 25 over 4. Alright, so let's go ahead and graph that. So our first point, 1/2 negative 25 over 4. I'm not going to do this exactly, I'm just going to approximate where that would be. We know 1/2 would be pretty close to the y-axis, and then negative 25 over 4 is a little less than negative 6, so I'm just going to put that about right there. And then we also know that this parabola is concave upward because the a term is positive. We mentioned that earlier. So if I can draw this pretty accurately, and I don't know if this is precisely where these points will go, but it will have this general shape. And now for the final piece, this would be the graph. If all we were doing was graphing y equals x squared minus x minus 6, then this is exactly what the graph would look like. But in the original problem, we were being asked to graph y plus 6 is greater than or equal to x squared minus x. So if that's the case, then we have to shade in everything that is not only on the line equal to, but also what's greater than. So what's greater than this parabola? Well, everything inside. So all of this would be considered greater than. And everything that's outside, everything that's out here, would be considered less than. And that's it.